Right, so in this video, we're going to be looking at division of polynomials and the remainder factor theorem. And before we begin, we're going to take a look at a very useful method that can help you solve these questions quite easily. And that method is called comparing coefficients. Say you had something like 4x squared plus 7x minus 1, and it was identical to ax squared plus bx plus 3x plus c. So as the name suggests, you're just gonna compare the coefficients. So in this case, you're gonna compare, let's say we wanna take a look at x squared. We're just gonna compare this x squared with that x squared. So in this case, you have 4x squared is equal to ax squared. What you're gonna do now is just cancel out x squared, and now you've found the value for a, which is 4. Likewise, we could do the same for x. In this case, we have bx and 3x, and it's going to be equated to 7x. So 7x is equal to bx plus 3x. We can cancel those out. And now we have 7 is equal to b plus 3, and your b is 4. Now say you don't have a value of x or something, and it's just a constant. You're just going to compare the constants as it is. And make sure you are vary of the sign. That is important. So in this case, c and -1 are both constants. So our c is just -1. Now we're going to take a look at a more advanced example, which is going to be 3x minus 1, x minus 5 plus ax plus b, which is like equal to 3x squared plus 11x minus 1. Now, what are you going to do now is just expand these two brackets. You get 3x squared minus 15x minus x plus 5 plus ax plus b, like that to 3x squared plus 7x minus 1. So now what I would like to do is get everything in order, basically. What I mean is that I want all of these x values to be together and all of my constants to be together, which in this case will give me 3x squared minus 16x plus ax plus 5 plus b plus 5 plus b, and that's equal to 3x squared plus 7x minus 1. So now in this case, we don't really have to compare the coefficient of x squared with the left-hand side because it's already done. We're going to take a look at the coefficients of x. So in this case, you have -16x plus ax equal to 11x. Let's cancel out x. We got -16 plus a equal 11, which will give us 27. And now with our constants, we get 5 plus b is equal to -1, which gives us b equals -6. So these are your two values of a and b. Now we're going to start off with a basic example of polynomial division. We're going to be dividing x squared plus 5x plus 6 with x plus 2. So what we're going to do now is that I'm going to show you two ways of solving this problem. First method is, so now you're going to have x squared plus 5x plus 6, right? X plus 2. So this is how we're going to start. And so now we have to multiply x plus 2 with something that would cancel out x squared. So what could that be? So if we just say x squared is divided by x, we get x. So what are you going to add here? X. And make sure you're subtracting and add a parentheses around what you're going to add here. So in this case, x plus x times x is x squared, and x times 2 is plus 2x. So now you're just going to subtract the 2. You get x squared minus x squared, which is 0. 5 minus plus 2x, which is 5 minus 2x, you get 3x. And we're going to take this down here, and we get 3x plus 6. Now, what do I have to multiply the divisor with in order to get 3x? Well, let's do that again. 3x divided by x is 3. So I have to multiply this with 3, and we're just going to add 3 to our quotient. And now we get 3x plus 6, which is 0. So in this case, our quotient is x plus 3. And before we continue with another example, I want you to understand the terminology for this sort of division. So this is your dividend, that's your divisor, that's your quotient, and that's your remainder. So what about the second method? The second method is comparing coefficients. So how are we going to do that? Well, you have x squared plus 5x plus 6. And that's pretty much identical to x plus 2. And we will have our quotient here. So in this case, it's just ax plus b. So you may be wondering why I've taken ax plus b and not some other sort of equation. And the reason for that is the highest degree of x we have in this example is just x squared. And if you expand these two brackets, you're just going to get a quadratic, which is what we're looking for. So now you're just going to expand the two. You get ax squared plus bx plus 2ax plus 2b. So now you're going to compare the coefficients again. And in this case, we're going to keep the ones in the middle for last. And you're going to understand why, because we could straight away find the coefficient of x squared on the right hand side by equating x squared is equal to ax squared. And when you cancel the 2 out, you get a is equal to 1. Likewise, you could do the same for the constant, which is going to be 2b equals 6, and your b is just 3. And just for your own sake, if you really want to, you could plug the two values back into this middle part of the quadratic, and you'll be getting the same result. So b was 3, so 3x, and a was 1 plus 2x. You get 5x, which is exactly what you need here. Now this specific example, x squared minus 2x plus 2 divided by x plus 1, requires you to find the quotient and the remainder. So we're going to take a look at two methods again, but first we're going to work it out with long division. So x plus 1 here, and x squared minus 2x plus 2 here. With enough practice, you could just straight away figure out, okay, that is what I have to multiply x with in order to remove x squared. So what are we going to do here? Let me just put the parentheses and a negative sign. And here we will get x. So now we have x squared plus x. These two will cancel out. Here you get negative 3x plus 2. Get that down there. And now you just have to multiply this with negative 3. So negative 3, and again parentheses, negative 3x, negative 3, minus 3. And now you get 0 here and 5 here. So your remainder in this case is 5, and your quotient in this case is x minus 3. So how are we going to solve this using comparing coefficients method? This is one of the division algorithm for polynomials that you need to remember. Dividend is equal to divisor times quotient plus remainder. After a good amount of practice, you will just immediately figure this out. So what was our dividend in this problem? It was x squared minus 2x plus 2. X squared minus 2x plus 2. And our divisor in this example was x plus 1. And our quotient again, like we had just done in our previous example, where we taken an arbitrary equation. In order to solve this, we're going to do the same thing over here. So in this case, we're going to take ax plus b again. And this time, since we're known to have a remainder because of this specific example of the question, and that's just going to be c. So let's expand this. X squared minus 2x plus 2 is equal to ax squared plus bx plus ax plus b plus c. So in this case, it will be quite troublesome to work out constants. So we're going to consider our middle part of the quadratic equation. So what we will do here is that first we'll just equate the coefficient of x squared, and that is pretty much a is equal to 1. And now we're going to compare the coefficient of x on the left hand side with b plus a of the right hand side, and we will get negative 2 plus b. Negative 2 is equal to b plus a, and since we already know a is 1, negative 2 is equal to b plus 1, we will get b is equal to negative 3. Right? So now we'll compare the constant now, which makes it easier for us. 2 plus 2 is equal to b plus c, and we know that b is negative 3, so 2 is equal to negative 3 plus c, and our c is 5. So as we can see here, the remainder that we got in this method is the same as the remainder we got in our other method. So we could just use this other way of solving long divisions. Or you could just use this algorithm to confirm that you get the exact dividend you were just working with. So now we're going to take a look at remainder theorem. So you must realize by the name itself that your polynomial that is going to be divided with some value is always going to give a remainder. So in this case, say you had a function of x and you divided it with x minus a. You will get your remainder for f of a, because if we just equate x minus a is equal to 0 and x is just pretty much a, you're just going to replace the function of x with a. And like we had just done with our previous example of x squared minus 2x plus 2, say this is your function of x, and we had divided with x plus 1. So in this case, your x value is just negative 1. And we're just going to replace this over here. So now we get f of negative 1, negative 1 whole squared minus 2 times negative 1 plus 2. And now we'll get 1 plus 2 plus 2. And our remainder here is 5. So that's the other way of finding the remainder. Now we're going to take a look at factor theorem. This theorem basically suggests that if you divide a polynomial, say a function of x, with x minus a again, you're gonna get f of function of a is equal to 0, meaning there are no remainders. So hence, whatever this is, that's your factor. So we're gonna take a look at an example of this. Say you had f of x is equal to 2x cubed plus ax squared plus bx minus 20. Say you divide this function with x minus 1, your function yields negative 42, which is your remainder now. And say when you divided it with x plus 1, your function gives 0, which means this is a factor. So how are we going to work with this if we have two unknowns of a and b? Well, you're just going to replace x with two of these values. So in this case, if you were going to start with x minus 1, which we're going to equate this to 0, your x will be 1. And if you replace x with 1, you're going to get 2 plus a plus b minus 20 equals negative 42. And now you can clean this up and say now we work with x plus 1 is equal to 0, which gives us 0. So in this case, x is equal to negative 1. And if you replace the function with negative 1, we'll be getting negative 2 plus a, negative b, negative 20 equal 0. So now you'll get a minus b, negative 42 and 42. So now you're going to find the two values using simultaneous equation. So now we will rearrange this and as 22 plus b. And now we're going to equate this into that. So now we can get 22 plus b is equal to negative 24. You get 2b and negative 46, and your b is negative 23. And if you put that to a, we're going to get 22 minus 23, which is negative 1. So now we're going to take a look at this problem. So now we're going to use long division for this question. let's write everything down here, minus 10x plus 8. And since it has already said that this equation is a factor of p of x, it just means we have 0 remainder. So now what we're going to do is that we'll be getting, so now we're going to divide this with x squared plus x plus 1. Again, I'm going to do this quickly, x squared parentheses minus and parentheses, x squared, x 4x. So we're going to get x to the power 4 plus x to the power of 3 and plus x squared. Now we're just going to subtract the 2, you get 0 here. So minus x minus 2x cubed minus 10x squared minus 10x. So we're going to multiply this with minus 2x and we'll be getting minus 2x cubed. Again, don't forget the parentheses. And now here we get a remainder of a plus 8. Didn't the question say that that was a factor of this function? It is. So our remainder should be 0. So how are we going to solve for a now? So you're going to equate a plus 8 is equal to 0 because your remainder is 0. So now your value of a is actually negative 8. So now you've found the value of a as well as the other quadratic factor, which is x squared minus 2x minus 8. So now we're going to take a look at the second part of the question. Solve the equation function of x is less than 0. So we're going to be working with the divisor and the quotient. And that's pretty much x squared minus 2x minus 8 times x squared plus x plus 1, as we have just seen with the division algorithm. So now we want to take a look if the two equations here are less than 0. And what that basically means is that this graph will be intersecting the x-axis at certain points. And to confirm that, we just have to use discriminant. So we know that there are two real solutions if it's greater than 0, one solution if it's equal to 0, and no solutions if it's less than 0. So now we're going to take a look at both of these discriminants individually. So we have 1 and 2. So the discriminant of the first equation will be b squared minus 4ac. We're not going to equate it to something yet. And we'll be getting 4 minus 4. A is 1 and c is negative 8, which gives us 36, which means this definitely goes below the x-axis, and hence we're going to try find the roots of the first equation. What about the second equation? The second equation, b squared minus 4ac, will be giving us 1 minus 4, 1 and 1, and it's pretty much negative 3, which means this equation provides no solution below the x-axis. So we're just going to be working with our first equation, and if we could find the factors, which will be x squared minus 4x plus 2x minus 8 equals 0, x minus x minus 4 plus 2x minus 4, and your two solutions are x is equal to negative, x is equal to 4. Now be careful, they've said less than 0, so you now need to find, okay, what is that region that they're looking for? It's going to be something like that's going to be your graph, and they want to know this region, which is pretty much x is less than 4 and greater than negative 2. Now here's one question of polynomial division where you have to be very, very careful with how you solve this. Say you have 6x to the power 4 minus 9x squared plus 18, and you divide this by x minus 3. Now if you've noticed, we don't have x cubed, we don't have x either. So how are we going to divide this? You're basically going to consider x cubed and x, but its coefficient is just going to be 0. And let me show you what I mean by that. Say you divide this, you will be having 6x to the power 4 plus 0x cubed minus 9x squared plus 0x plus 18. And now you're going to divide this by x minus 3. you'll be getting 6x cubed on top here, not minus in parentheses. You're gonna get 6x to the power 4. And now minus 3 times 6 is negative 18x cubed. Now we're going to work with this. 18x cubed minus 9x squared. You're going to get plus 18x squared, which is just 18x cubed and negative 54x squared. You're going to get minus 9 plus 4, which is 45x squared. We're going to have 0x here, plus 0x, minus, now you're going to have 45 there, 45 x actually. So x squared. 3 times 45 is 135, which is pretty much negative 135x here. And you're gonna get 135x plus 18 at the end. Multiply this by 135 now. You're gonna get 135x parentheses 135 times negative 3, which is now negative 405. And now your remainder here is just 423. And now you're going to get 6x cubed plus 18x squared plus 45x plus 135 plus 423 over x minus 3. And that is done.